Hi and welcome to Math Pre-Calculus 20, Section 5.3, Solving Radical Equations, Example 2. This question asks what are the restrictions on n if the equation n minus square root of 5 minus n equals negative 7 involves real numbers, and then solve the equation. So first off, the restrictions part. So basically what values of n are allowed here? Well, first off, this n, it could be anything. Could be positive, could be negative, could be 0. It's not going to affect our answer. So this n here under the square root sign is the one we need to be concerned about. So basically, right, anything under a square root sign, right, has to be greater than or equal to 0. If we have square root negative 1, right, it can't be done. So basically what we want to do is just take whatever's under there, so in this case 5 minus n, and we say it has to be greater than or equal to 0, and then we just solve this for n to get a value for n. So if I add the n to the other side, I get 5 is greater than or equal to n, or writing it the other way, n has to be less than or equal to 5. Right, so if n is 5, this would be 5 minus 5, which would equal 0, which is good. If n was 4, it would be 5 minus 4, which equals 1, which is good. Right, and it could be decimals as well. Right, so I'm just going to erase that stuff there, and now let's look. So this here is our restriction, okay? Now looking at the next part, the solving of the equation. So solving radical equations, we've got n minus square root of 5 minus n equals negative 7. So what we want to do is isolate the radical part if possible. So in this case, there's only one radical, right? It's the square root of 5 minus n. There is just one of it, so we can isolate it. So to do that, I could subtract the n to the other side. So I have negative square root of 5 minus n equals negative 7, take away n. Right, that's a little bit ugly with all the negatives, so what we could do is we could divide everything by negative 1. Right, as long as we do it to both sides of the equal sign and to everything, we're allowed to do it. To get 5 minus n equals 7 plus n. Okay, now what we want to do is get rid of that radical sign. So to do that, we square both sides. So right, the first step in solving a radical equation is to get the radical by itself. Second step is to square both sides. So now when we square this, all we get is 5 minus n. We square this side, it's FOIL, so it's 49 plus 14n plus n squared. And then usually we end up with a quadratic. Not every time, but usually we're going to end up with a quadratic. So in this case, we end up with this here, and let's just take everything to one side to see what we have. So if we take everything to one side, and I'm just going to rearrange things a bit, we have n squared, and I'm subtracting the 5, and I'm adding the n. So we have n squared plus 15n, and then plus 44, and then hopefully we can factor it. In this case, looks like we can. Right, we need a product 44, sum of 15, so those numbers are 11 and 4, so I have 0 equals n plus 11, then n plus 4, and then solving it we have n plus 11 equals 0, n plus 4 equals 0, so n equals negative 11, and n equals negative 4. Okay, those are our two solutions. One thing we should check is that, first off, do these fall within the restrictions? So the restriction said that n has to be less than or equal to 5. Are these both less than or equal to 5? Yes, they are. So that's good. If they weren't, we would cross them off. And then the other thing to check is just, do they work in the original equation? So for example, we had n equals negative 4, so be negative 4, take away square root of 5, take away negative 4. Is that equal to negative 7? So it's negative 4, take away square root of 9. Is that equal to negative 7? So negative 4, take away 3, yeah, equals negative 7. So that solution works. And we could go through the same process for negative 11 as well, and we should find that they both check out. I haven't actually checked for negative 11, so you might want to do that quickly and just double check. Alright, thanks for watching.